Have you already worked with it? How far are you with the system? Multi-channel is known, ZEISS is known, time-lapse is known?
ZEISS is something that I can do it.
Yeah. But we start there, so more or less.
Yeah, I have a sample I wanted to test
Yeah.
on that if we can,
Sure.
but I'd rather do it in the dark because
Okay.
it will bleach.
So a quick introduction, that's Sven. He's our
Yeah.
imaging specialist, so he's actually technically, while I've trained you guys on most of the software, he's really the specialist. He's the guy who knows inside and out of the software. So especially when it comes to setting up long-term or more complicated experiments and all that. So that's why I brought him here.
Right.
So, yeah. So if you actually have samples and actually imaging parameters that you want to
Yeah.
build with, now's the time to do it.
Yep,
Okay?
I got
Look
it.
at them.
Yeah, when he's done, we can do it in the
Just
dark.
want to first have a feeling where you are comfortable to and where not anymore. So, like with the software, the locate button, everyone knows how to use the locate button? Or yeah? Okay. So then...
Can we go from 0 for the video? I mean, like, if we don't know anything.
Oh, yeah, sure we can. That's why I was
So
asking.
Andrew, this
Okay,
one- this
so
one, right? So this
Before
one-
you start up the ZEN software, always make sure that all the hardware is switched on, which is the the microscope and the camera. And if you want incubation, also the incubator. Yeah, on the bottom of this one.
This chamber here, right?
So then, when you
This
start
is
up the
heavy,
software,
it's gonna go down
you will see here active camera Hamamatsu camera available. I started it up here first. Initially, I forgot to switch on the camera, so then this one here would be empty. Now you have 4 tabs. The first 2 are the ones that you will mainly use. It's the locate and the acquisition tab. Locate is really meant to look at your sample, to find your sample through the binoculars. And then afterwards we go into acquisition. So what I'm going to do, the easiest way to work is you have here shortcuts. So you only have like 3 filters for fluorescence anyway, and then bright field. Just click one. And now all the light is coming through. And if I open up the light path, I can fully control my microscope. So I can now click on oculars here. Now the light is going to the oculars. I can look here, I can focus, or I can search for another area.
Figure out like how much pressure you go. Use
Like
cells
this
to
one,
tell
for
you
example.
if you're happy
Once I found the area, I can now look in another color for the dye, for example my red. Again, to the eyes. Okay, I'm fine here. I could look at my DAPI as well if I want. Just don't forget, when you click here on the dye, also select binoculars. Or if you click on a dye, just click on live as well, and then you actually get to see here your image. Yeah. So now you can focus on the image itself. So basically, once you found your area of interest, you click all off, light goes off. Now we're going to start our real acquisition. So we go into the acquisition tab. In the acquisition tab, there's 2 easy ways to work with. First of all, you have here default all channels new. When you open it up, you have all the possibilities of channels here. I'm just gonna check, you have 4 filters, yeah. So you have a filter for DAPI, you have a filter for GFP, FITSI, Alexa 488, basically blue, green, 1 for red. Transmitted light, there's also this one, which I quickly want to check what it's actually doing, but nothing special. Nothing at all. So, and calcium is basically the same as green. So the ones that you will mainly use are the first 3 and the 4th for transmitted light. That's actually what you should be focusing on. So the only thing you need to know is what are the dyes that I'm using in my sample, and you enable those dyes just by clicking in front. I now have a sample with DAPI Alexa 488, which is green, and Alexa 568, which is red. Once that's done, I can click on live, and based on my live window, you can always click min-max to get a bit more light if necessary. I can see here my nuclei in blue. When I click on EGFP, I will see my green dye showing up soon. can focus. When I click on red, it will go into the red fluorescence. Per channel, I can now set my exposure time. So I can do this manually, or I can also just click here on the top on set exposure, and then the software will automatically define the exposure time for you, the most optimal one. Here is my live window. If you want to move around in the live window, you can do this with the joystick, or you can also just go to the borders or the corners to move immediately a field of view, like I'm doing now. Yeah. If, for example, you want this cell nicely in the center of your image, just go there and double click, and the stage or the microscope will center the cell for you. Yeah. So once the exposure time is set correctly, once you have your field of view set correctly, when you do snap, it will automatically acquire an image for all the 3 tabs. Don't look at anything overexposed, it will compensate. So now, here we go.
Really great.
Yeah. So then min max or best fit gives a little bit more contrast in the image. Don't be afraid to use this. This is only visualizing. It's not changing the values of the gray levels in my image. So I can still do my analysis of intensities if that's of interest. Yeah. Now, to acquire a Z-stack of this, it's a little bit difficult because my cells are very, very thin. But what you have to do is just enable here Z-stack. And as soon as you enable Z-stack, you see here on the bottom appearing full Z-stack per channel or all channels per slice. Full Z-stack per channel is the fastest. I'm going to do all my green, all my red, all my blue, and then it's combined. All channels per slice means blue, green, red, next level blue, green, red, next level blue, green, red. But then it's constantly switching the filters, which is a slower process. So I enable full Z-stack per channel. Again, I go live in one of the colors. The color that's for you representative for the thickness of the Z. I go into Z-stack. I now focus manually to the lowest Z. For example, here, set first. I go to the other side and I set last. So I now define the borders of my Z-stack. Then I click on optimal. This is my optimal step size. Once this is done, everything is set. You had a question?
I did have a question. So when I've done this in the past, I set my first and I set my last, and it'll automatically change the number of slices to something that's way higher than what I wanted originally. And then when I go in and I change it, it'll change my first and last. Is there a way I can make it so that
if you go to
manually
show all, maybe one of these, maybe the slice was set.
Oh, that was probably it. Okay.
Yeah. So if, for example, you don't want an interval of 0.86, but you want larger step sizes, just I can now double this 1.72, for example. That's double, and it will adjust the number of slices. So for the same range, I still start and stop at the same place, but I do less steps now. So once this is done, I can now click here on Start Experiment. It's illuminating first for the red. You see it moving along. Then for the green. And now for the blue. And below my image that's being created, I see now a slider, my Z position slider, where I can go through the Z. Yeah. Or best fit. On the left of the image, you also have a split screen, which shows you the green, red, green, blue, and merged view. You can slide through. You have a gallery availability where you can show, for example, the dimension labels. Here, very, very tiny. If I zoom in, this means zoom in on all. With this one, I can zoom in. It shows you the depth value that I've been imaging. Switch this off and I zoom to 100% again. Or 2D shows everything again. Next things I have is also an ortho view, orthogonal view. This is my XY view. Here on top is my XZ, so it's looking from the side. And here is my YZ view. So I can now mark a region and I can look from the side how my cells look like. Why is this ortho view also important? Because on the bottom you also see maximum intensity projection. This is how you make an MIP. Just enable it. All my images are now merged into one in Z, and now I can say create current view, or for example only the XY plane. XY create, and you can work further with this one. Cut view and 2.5D is mainly used in materials microscopy. The 3D button can be of interest. Here I can really look at all directions at my Z stack, so I really have a 3D image now. On the bottoms, these knobs are to rotate in all three directions. This one here on top is to zoom in. Don't be afraid of those lines that you see. That's an effect of the video card, because it has to calculate all the positions in between. The house that you see here is always go back to normal position. Histogram is giving you the intensity distribution of each color over the image. Profile is you can draw a profile line over it, and then you can use this to measure distances based on the intensity peaks. If I go here to caliper, for example, from this fiber until that fiber, based on the intensity peak, I now have at table a distance of 8.05 micrometer. So it's an easy and fast way to measure distances between something based on the intensity distribution over the line that you draw. Measure, we come to that later on. Well, actually I can show it now as well. So what I can also do in my 2D image, I can go to graphics, and here I can mark regions, rectangle or circular or free area region. So the more you click, the better you can surround the cell. You right click to close it. If I now go to measure, I get a table for this area. I get the area in micrometer, the intensities of each of the dyes within that area. And you can draw as many regions of interest as you want. Next thing, we had Z-Stack. We can go to time series. Of course, you can combine a time series with the Z-Stack as well. In the time series, the only important thing to do is tell the software how many cycles or how many images you want, or for how long you would like to image. It even goes up to days if you want. So for example, 10 cycles. And tell the software what the interval has to be. For example, every 5 seconds. So in this case, I'm going to require 10 images with 5 seconds interval. Just to speed up the demo a bit, I'm going to disable my 2 other colors. I only keep the green, and I click Start Experiment. It's illuminating for the green. It's off. 5 seconds countdown. You can follow the countdown here and again. And next. And now below the image, instead of dimensions, you see a time slider showing up. Also here you can now, with graphics, mark regions of interest. It's not finished, but I can already draw them. I don't see it anymore. It was dark blue. Again. So here is my time lapse now. I can now go to mean ROI, and now it will actually show me, if I draw an area here, it can show me the intensity distribution within that area over time. So here you see it's going down. That's because I'm actually bleaching my cells. Also here, don't forget, you can mark as many areas as you want. So in case you want to do this kind of analysis, never forget to also mark a region in the background to look at the normal decay of the fluorophore or possibly the light. That's the time series. Time series combined with ZEISS Axio, no issue. Tiles, and tiles goes a little bit further than this. Because I first went to ZEISS Axio and time series because those are the easier modules. The tiles module goes pretty far. So what can I do with the tiles module? I can mark this region, this image as the center. Here I can say, for example, 4x4 plus this will be the center of my image. If I now hit start experiment, at the resolution of a small image, I will now actually cover a large image, large area. So basically this could be my field of view now of a 10 times objective while I'm doing it at a 40 times. So I have the higher resolution of the 40 times. So here you go. So that's a tile. You can, however, also do positions. So if I delete this one, for positions I go into live, I need my joystick, and I can now say, okay, this cell in the center, position, and now I move along and I look for my other cell, oh, this one here, plus, and oh, this one was nice, that one also there, and plus. So I now have 3 positions. I can combine this with a time series, maybe 4 cycle and just constantly, so 0 interval is constant. If I now hit start experiment, the software will go to each of the 3 positions and then repeat it for the time that your time series is active. Here on the bottom I have now 2 players. I have my timeline and I have a scene. The scene are my 3 different positions, and then for each position I have a time lapse. So this is 1, the time lapse, 2 with the time lapse, and 3 with the time lapse. When I switch off scene, you get an idea of where I actually acquired the images, how far they are apart from each other. That's the easy way to set things up, but also the most limiting way. When I enable show all, you will see here in the options that I can have an overlap when I acquire my tile image. Always see that you have a certain overlap. That was this one. Because if you have an overlap, you can go to processing, method, stitching. The image is automatically selected. You click on apply, and now the software will look for, between the images, will look for similar objects and realign the image so that it's perfectly flattened. perfectly aligned with each other. Right? So this was the default. Reset. You see there is some shift ongoing.
Yeah.
Now I'm back to how it was before. If I zoom in, you see here the line.
Mm-hmm.
Right? So once I do the stitching, it's taken care of. You don't have lines anymore. So that's why this 10% overlap or more is of course of interest. Another button that can be of interest is the custom stage speed. If you work with cell culture where the cells are not very well attached to the bottom, the movement of the stage for multi-position might loosen that because it's shaking a lot. So here you can change the speed of the stage moving around. Instead of 100%, you can say 50 or 80% or whatever. So just slow it down. The software will always wait until the position has been verified before acquiring an image. So don't worry about slowing it down. Now, we also have the advanced setup window here. Why is that one of interest? Here I can zoom in with the wheel, scroll. This is my image. Here on the bottom I can now also create my tile region. I can define a contour, this one, and it will automatically define how many images I need. I can also say predefined, as I did here, 4x4 or 4x6. I select the tool, I click on it, and this is the area I will cover. Now I can double click here and my stage will move there and I can see if I'm far enough or not. If I'm not far enough, you can extend it even more. You also have stake.
So, sorry, just
Yeah.
a quick question. That lets you predefine a spot and then take images around that spot?
Yeah, so this is where the stage is right now.
Mm-hmm.
If you zoom out too much and then zoom in again, you will see it will disappear outside. Here you have center to stage. That's important. So this is where I am right now with the stage. And now I can say around this spot I want 5x5 images or 4x3 or whatever you need to choose.
So it'll go up some
Yes.
amount, take a picture, go up again, take a picture,
Yeah.
go to the, and fill in the grid.
Well, it will always start on the top left and then go down.
Okay.
Now, this was based on tiles. I can also base it on stake. And what stake is doing is, I now move to the top left. This is very interesting if you have tissue, for example, tumor tissue. You define the top left part of the tissue, the highest part of the tissue, and you say plus. Now I define the top bottom, right, and I say plus, and automatically it will define how many images have to be taken in between to cover the complete tumor. So basically, if this would be my object of interest, you define the area here, here, and the software will calculate what it takes to acquire all that.
So what's the yellow line then?
The yellow line is the movement. If I extract this a little bit, you need, sorry, one more. You need one row of images
Okay,
more to
okay.
cover it. So somehow it's always, it's not exactly the center. It also takes into account the 10% overlap. But you can freely move around here. Now what else can be of interest is you also have a 10 times objective. Imagine that you want to acquire multiple positions and your object of interest is actually quite big, but you only want to acquire a few spots on it. You can switch to the 10 times objective. In channels you will need a longer exposure time probably to cover for. You can always go to display. It's still quite okay. And click min max. So now I focus. See, my field of view is now larger. My cells are becoming much smaller because it's 10 times, but my field of view is larger. Now I can mark a large field of view via contour. This one. With the 10 times this will be done quite quickly. But here on the right I have preview scan. I can now say with the 10 times start a preview scan. And instead of creating a real image, it will make an image in my Tiles Advanced setup.
Does it maintain the exposure time?
In this case it did, but
If you click auto, it might change between.
It might
okay.
change, yes. Well, that's why I opened the channels window, because I expected that I had to change it. It didn't. I was lucky. And you can clearly see where I've been imaging before. Okay. So now it's finished. Automatically the light goes off. I can select the yellow line here, or I can just go to my tiles window and I remove this region because I don't need it anymore. What I can do now is I can zoom in. I have lower resolution, but that's okay, because all I need to do is I go to position setup, I select location plus enable to keep tool, and now I can just select the cells of interest that I want to follow up. This one maybe, this one, and this one. So I have 5 positions now. So in tile regions I don't have anything anymore, but if I go into position, I see here my 5 positions. So now I can switch back to the 40 times. I ask for a live window. And I click on verify positions. And now I say for the first one, move to current position. I refocus. And I say set current Z, move to next point. Again I refocus. Set current Z, move to next point, and I repeat this for all my positions. Basically, just because I switch from 10 to 40, I have a slightly different Z position. I have to refocus, but I just quickly check it. Once I've done all, everything will have a green light and I can close it.
What is the image on the right? That's just the next
That's
image in the
from
grid.
my 10 times in the background. So set current Z, there is no next point anymore, so I go close and I can stop my live image. So this was from my 10 times overview image, which is out of focus or whatever, but often I don't really care that much. I just want to have an impression of where is my tissue or whatever. So I have now 5 positions. They are in focus. I can combine this with the time series, with the Z stack. In the Z stack, instead of doing first last, I go center. Once in center, I defined only for one. This is my center position. But what's now important is the focus strategy. Because in the focus strategy, I have to choose absolute fixed Z position, use the Z from the tile setup. Because for each of the positions I use a different Z, it's now going to use that as the center of my Z stack. So I can combine with time series. I'm going to do it now with just with the Z stack when I hit start experiment. It's making small Z stacks for all of the positions. And this I can repeat and on whatever you're looking at. You know, what is, you're looking at cell culture here or zebrafish?
So far, yeah, cells.
And again, I have here my scenes, so my 4 positions, and for each one of them my Z stack. I can also switch it off, and you see how far they are. Sorry for that. So, have my 5 positions. I can slide through Z all at the same time, or one by one. One other thing you can do in the tiles window, if you're using a lot of well plates, is that a sample that you have with well plates?
So we have 24 wells.
Okay, then we will.
There's only 3 of them.
Okay, I will show you how to calibrate it on your sample. But you can also, instead of positions here, I'm going to delete all of them. I go into my tiles advanced setup window. I can also have a sample carrier here. Open it up, you select, and from this list you can choose the one that you have. Multi-well 384, 96. If the one you have isn't there, you had the 24, is it?
24, yeah.
What you can do is you go to the multi-well 6, here on the bottom with the small wheel, copy and edit. Multi-well 24. I have 6 columns, 4 rows. Now I just have to make my circle smaller. I don't know exactly how small they are.
They're almost touching, so bigger than that.
Yeah. Well, this is the diameter that I'm changing.
Yep.
So I have to measure the diameter of each well, and then the distance center to center as well. So I would really have to measure it on a sample from you. Is that maybe 15 by 15? I don't know. Might be close,
yeah.
but we would have to really measure it and create it
Okay.
like that. So you can create your own well plate. We can do that afterwards. Just to show you what you can do in the multi-well 96, I click OK. I already created position, so it asks me to override. I say yes. Here I have now my well plate. Here on the left bottom, I can now select the first row, for example, or with the control button, I can select a few out of that. With the shift, all of them. In the tile regions, I can go to carrier and I can say cover 25% of each well with the tile. And these ones here, I want covered for 100%. So if you now zoom in, this is 100% covered. So it will really make a lot of images, but I'm sure that I have the complete well image. Oh.
The yellow
Oh,
ones
no,
were
it
the 25.
Yes, but it automatically adjusts for all of them. This would be what's 25%. But you can also, instead of doing one large image, actually, you can also mark points of interest via the position setup. You can mark points yourself, or you can ask the software via carrier, distribute me 25 points in each of the wells. Or do this, but where are my cells typically growing? Towards the edge, more focused onto the edge. or more focused into the center. Or if you want to work biased, unbiased, you choose random, and it's really randomly distributed.
What does the bias and unbiased do?
No, sorry, if you define the positions, you're actually biased. So if you click on random, the software is doing it for you, and that's unbiased. So for analysis. I once got a paper back because it was so called biased, and I had to do it this way, in a similar way. That time the ZEN software didn't exist. But so just removing this. So you're really free to define whatever you want for your well plates, and for a well plate, this can go much faster than marking the positions yourself. I know. Yeah.
Just to clarify, is this looking at it from the bottom? Because I know we were visualizing the place from the bottom. But is this choosing the points looking at it from the top?
Yes, because
That's
this is
looking at- okay.
A1. So this
Okay.
is really your left top corner
Okay.
from the top. Okay. Any questions up until now about
Yep.
this?
So when you did a Z-stack and you got into 3D and you were able to click and drag it around,
Yeah.
is there any way you can export something like that? Or is
Yes.
it only visual?
No, where is my Z stack? This is my Z stack. I click on 3D,
Yeah.
so I can rotate this via series here. I can now say turn around X. It's not done often. Turn around Y. This is much more used.
Yeah.
Especially here, I can define whether I want to turn around 360 degrees or this rocking model. So if I now create this number of frames 30, for example, or 50, you're free to define. I can do a preview. It's this
Yeah.
going back and forward. This is something you see often in the presentations.
And there's a speed. You can set
This
it-
is the number of frames, yes.
number of frames is the speed. Okay.
No, this is the number of frames being calculated.
Okay.
Some fixed positions. But this was just a preview that I showed. I actually have to calculate the real image. So for that I click on apply. So now it's creating a new image. If I go into player, this would be my
Yeah.
rocking model. Here I can define the speed to visualizing the ZEN software. If you want to import this in your PowerPoint presentation, you have to go to processing. Under method, you go to not image export, but movie export. Where is it? Here. In the parameters, you can now choose AVI, that's good, original size, quality, whatever. Here you do the mapping 1 frame per image or 5 frames or 8 frames or whatever.
Okay.
So that's your speed that the final AVI file will have.
Okay.
Hey Sven, you okay here by yourself?
I'm okay here, yeah.
It's good guys harass you. Just kidding. I have a family commitment to run to, so I'll see you next week.
Enjoy.
Thank you.
See ya,
Good
thank
you.
guys.
Thank you.
Learn as much as
Appreciate
you
it.
can from him.
Sure. Thanks.
He's knowledgeable in the software, so and good luck with the lifestyle experiments.
Thanks.
So that's how you acquire or make the movies from it. Now there's one other thing is the deconvolution.
You said deconvolution?
Deconvolution.
Yeah.
So deconvolution can make optical sections for you. As you can see, when I go through my Z-stack, I have some autofocus light. Here not so much because my cells are pretty flat, but still I can improve this. To improve this, I have deconvolution defaults. Not much, so automatically my image is chosen again. Not much to choose from. Simple, better, good, or excellent. Basically, very fast, very slow. Yeah, that's what it is. Excellent, of course, is always the best. That's a constraint iterative, but it can really take, if you have a thick Z-stack and combined with a time lapse on multiple positions, can take hours to days to calculate. A good solution often is a fast iterative. You choose fast iterative, click apply. And now he will be also calculating some time, it will take a little bit. But yeah, it's an alternative. If you want to quickly check whether deconvolution will give you a better result or not, choose with simple very fast or so nearest neighbor or regularized inverse. Yeah. The regularized inverse filter is also a pretty good one. Now the constraint iterative, as I said, that's the best one. Why is it the best one? Because it not only looks within each image plane but also in between the planes. So it compares. Once it's on the second plane, it also looks at the first and the third plane, for example, for information to improve the second one. That's why it takes much longer. Is deconvolution something you guys are gonna use a lot or thinking of?
I'm thinking, yeah.
Yeah. Because you can also do this in batch. That's of interest.
And then just leave it.
And just
Okay.
leave it over the weekend. Because otherwise, like now, you will just be sitting here image,
Yeah.
image by image. And I mean, if you bring some movies, there's nothing to it. So,
It's going through all the Z stack right now.
it's now, yeah, now I only
Okay.
had 5. So this is now my center Z stack. And you see how it actually pushed to improve the contrast and the resolution, but for each, as good as possible for each of the planes. And actually it did a pretty good job except for the first plane in the red and the green. There I still have some fuzzy light. The other planes are way, way better than they were before. It's also pretty strong deconvolution being applied now. So the effect is extremely strong. But if I now go into 3D, you have a much better definition of each of the single points. Deconvolution defaults, as I said, select one and it will just do it for you. You have nothing that you can change here. That's different with deconvolution adjustable. And I can't drag it out, unfortunately. Okay, this is better. The deconvolution adjustable, I can now choose here in the parameters which algorithm I want. Again, I would suggest regularized inverse and fast iterative, unless you really have a publication valued image.
Mhm.
Yeah, then you go to constraint. If you go to constraint iterative, I'm going to show that one, you will see how many different parameters you can set. First of all, you can set different parameters per channel. You have normalization or clipping. What does that mean? Once it hits a black border, it might be that it actually calculates negative intensity values. When it's set to automatic, it will shift the gray value so that it all fits. When it's set to clip, it will just cut away those negative values. This means if it's an image for publication or for real showing, for visualization, you can definitely use clipping. If you want to do analysis on it, measuring intensities, you should do automatic. That's the difference. Yeah. Under corrections, I can correct for lamp flicker. So these halogen lamps, or this is an HXP lamp, they can flicker a little bit, and per Z stack I might have a different intensity illumination. That's possible per Z plane. Maybe we don't notice, but the software might notice because it's very small. So you can cover for it, just enable it. The more you enable, the longer the calculations will take. Fluorescent decay. If you acquire a Z stack and it's pretty thick, you're actually bleaching while you're imaging. So also the parts that you haven't imaged yet. So fluorescent decay will cover for that. And then background. Here my background in my original image was pretty dark, but if you have some background noise, some green, you can also cover for that in background too. Under advanced settings, Poisson, zero order, analytical, input image, and the iterations, and then the quality threshold. These things by default in 90% of the cases you will use these these settings for these parameters. When to change it, I'm going to show you here. You click on the question mark on top, you click on the part of the software you have a question about, and software, the help file will take you there immediately. Why am I showing you this? I can explain you this in more detail, but you will probably forget anyway.
Yeah, we will.
So you just click on this question mark code there, and then you have here list of deconvolution methods in ZEN Blue, nicely explaining what it's all doing. Constraint iterative, fast iterative, and all these things. Adjustable parameters. You have here the deconvolution tab. That's the one we are in, and here it's explaining you what every single parameter is doing. Adjust strength. Then we have the Z-stack correction. Advanced settings. Advanced settings for, in this case, iterative algorithm. Zero order, first order, second order. That's this one here. Yeah. So you can just read and you can define what might be the best one for you. As I said, in most of the cases, this will be a good setting. The only one that you might really want to play with is maximum iterations. Maximum iterations is once an image has been calculated, the software will compare the results of the calculated image with the original. If there is not much difference, it will do another iteration. It will run the deconvolution again and again compare it. And it will do this maximum 40 times. This also defines the time for deconvolution. But at the same time, it also slows down your time of processing. So the higher this number, the longer the processing will take. 40 is kind of a magic number that's being filled in. Often 5 or 10 is already a good number as well. Yeah. So don't forget this question mark here on top, and then just click that.
What's the default maximum iterations for the automatic, not the adjustable deconvolution?
It's also the 40.
It's 40, okay.
Yeah, yeah. So I haven't changed anything here. So the values that are set here is actually the values that are being used by the default. So nothing here, Poisson, zero order, analytical, 40 iterations, quality threshold 1. That's what's being used by the default versions. Same for fast iterative, what I just used was Poisson, no regularization, no optimization, but 40 iterations as well. Because I don't have these here, that's why my iterative algorithm is faster than the constraint iterative. So enable channel selection enables me to set different parameters for each of the channels. And then we come to the PSF settings. The PSF is actually particularly linked to your microscope and your objectives. So right now I was using a theoretical PSF. Have you ever heard of PSF, points per function? So what you have in a microscope is convolution, and that's why you want to do deconvolution. So if I look with the microscope at a very, very small spot, my very small spot is actually growing because of all my lenses. So my very tiny spot, it looks bigger in the microscope than what it actually is in reality, but it also has some diffraction. The light is going in all directions, and that's also what's causing this out of focus light that you see leaking through, because light from the bottom, light from the top is passing through, because there are also photons coming from it. So I have a certain distortion of my microscope, and this one is typical for every single microscope. Every microscope has its own unique distortion. You can use a theoretical PSF as I now did. Just don't fill in anything, skip it. It will calculate for you here PSF view. I can show you how it looks like. So this is the distortion of light from a very small dot with your microscope, theoretically. See, there's light going to the sides, there's light going to the top and to the bottom as well. This is distortion. So what is deconvolution doing? It's pushing all those photons back into the center circle. You can define your own distortion yourself with nanometer size beads. So you take fluorescent beads from, for example, in Vitrogen, 100 nanometers in diameter. You acquire a Z-stack of it, very small, and then you can go here in methods. You can go to create PSF. So you load your bead image. This, you don't have to care too much about it. You click apply and an image will be calculated which is showing you the PSF of your microscope. So this one is very symmetrical, so the left is exactly the same as the right. Probably your microscope will have higher deviation to the left, less to the right, or vice versa. That's quite typical. And then your deconvolution will also take care of that. So it knows it has to push less on the right side, but a bit more on the left side. So also this is nicely explained in the help file, so don't worry too much about it. I would always suggest to first check a couple of times with regular theoretical PSF. If you think like, okay, this is fine and it's good enough, then you don't have to worry about it. Otherwise, you can always go there and do it. Now, what is also very important for deconvolution, one error that I made here is, where is it? Here. Is my Z-stack did not start at the furthest out or the lowest position and the highest position where I don't have photons anymore. So if you want to do constrained iterative, the best deconvolution, you actually have to define a Z-stack not from out of focus to out of focus, but beyond that. So if you say here I'm in focus, I started my acquisition from here until here. While everything is in out of focus, I still have a lot of light. So actually I should start my Z-stack somewhere here until somewhere here where the light is much more dispersed, where I don't see any structure anymore whatsoever. This means that now my Z-stack is suddenly a lot bigger. Before it was 5 micrometer, now it is 355 micrometer. So my Z-stack acquisition is going to take much more time as well. But these photons that you now see in the image, they are still coming from your sample. So the deconvolution will still push them back in there. The final result will only be better. My result here is quite strong. See, it looks like it has been eating a lot from my sample. That's because I'm missing a lot of photons that were out there as well and not captured. So the software simply can't know. There's a little bit.
Lots of stuff I
It's-
didn't know.
It's a tough subject,
Yeah.
deconvolution. Yeah. What I would suggest is when you start with it, just go first in the adjustable, in the default,
Mhm.
and have a look at your samples, and then start playing around a little bit. One nice way to play around with your image acquisition. 207 slices is gonna take quite a long time. Let's try. It's not too long.
What is that?
Oh, it's the lowest position. Can't reach it. So let's say I go from here. To here, I don't have structure anymore. And my focus strategy also. This I have to switch off. Don't forget this one. Focus strategy to none if you don't do multi-positions. Otherwise, these weird things can happen. So via the edit button, I can mark a small region of interest and then cut that out of the image. Okay, so draw, edit, region of interest, draw region of interest. I can draw a small region of interest here. Again, edit, region of interest, create subset. So I actually create a new image only from that, but I have the complete C. And now I go into processing and I can do the deconvolution, whichever you want. Fast iterative, for example. Maybe 20. And now my deconvolution itself will also go much faster because it doesn't have to do so many pixels anymore, and you have a good idea of the final result. How does this look like as compared to my original? It's already much better. I have a much higher resolution already. So this cutting out a small piece is very easy or very good if you want to fine-tune your parameter settings. Okay, I'm gonna close all, window, close all. I don't want to keep them, so unselect all. Okay, and everything is closed. Let's have a look at your well played.
Kill the lights.